What's up everybody, my name is Tommy Franco. I'm a junior at Roger Williams University and I plan on majoring in mechanical engineering. Today I'm going to show you how to use the Baal's wind tunnel, which is a wind tunnel that was designed by Donald B. Baal, who's a former NASA engineer. So the wind tunnel is made out of plexiglass, fiberglass, and wood, and it's divided into three key sections. So the first section is the entrance cone, and the entrance cone has, as you can see, a honeycomb like mesh, if you will, which will straighten out any swirls that the fan pulls in. The next section is a test section. It's 7 by 10 inches and it's made entirely out of plexiglass, and this is what houses the airfoil that we'll be testing, and you can change the angle of attack or the pitch of the airfoil based on rotating it on a dowel. And the last section is the diffuser section, which is where the air is funneled out. And as you can see, there's a styrofoam center body which redirects the air that the fan pulls out so it doesn't interfere with the motor's performance. The purpose of this demonstration is to show airflow about a wing at different angle of attacks. So using smoke bombs to show the velocity streamlines going over the airfoil, we'll be able to see either laminar or turbulent flow as we change the angle of attack on the airfoil. So now the wind tunnel is set up outside, we are now ready to begin the demonstration. For the purpose of this demonstration, we are going to assume that the airplane is going to be taking off, so the airflow over the airfoil is going to be very fast, and after a certain period of time we'll begin to change the angle of attack. We're also going to assume that it's a standard aircraft, so we'll use a fairly small airfoil with a low camber, and as you can see, the chord line here separates your upper and lower camber, and you have your leading edge and your trailing edge. So this is going to work by dropping smoke bombs into the holding chamber, and as the smoke begins to dissipate, it'll travel up through this metal tube and it'll travel into the test section. The air will then be pulled by the fan and you'll be able to see streamlines very, very clearly. So without further ado, let's begin the demonstration. We are now going to light the smoke bombs. Turn on the wind tunnel. So, as we could see from the demonstration, at zero angle of attack, the flow was pretty laminar over the airfoil. As the angle of attack began to increase, less and less air was going over the top and more air was being redirected down, which, yes, will give you more lift. However, too much lift will cause no airflow over the top, and this is how a plane would stall out. We can see from this diagram that as the angle of attack increases, the streamlines become more scrunched together. Air moving over the top is in a low pressure system and is at a very high speed, whereas the air underneath the airfoil is in a high pressure system and is at a slower moving speed in comparison to the air going over the top. turbulent air begins to form on the trailing edge and will slowly work its way up to the leading edge until the leading edge is either completely vertical or close to vertical, in which no airflow will be seen going over. And this is how a plane is stalled, and the one way to get out of a stall is to dip down to regain that formation between the boundary layer. So this concludes the demonstration of the Baal's wind tunnel. I hope you enjoyed, and I hope you learned a lot, and thanks for joining.